Hi everyone, today I'm going to teach you how to do percent composition. Alright, so percent composition indicates the relative amount of each element present in a compound. You're going to need your periodic table and calculator for this lesson, so make sure you have those two things. Okay, so three steps here. 1, calculate the total molar mass. Again, you're going to need the periodic table for that. 2, divide the subtotal for each element's mass by the total molar mass. And then 3, multiply by 100% to convert it to a percentage. So just some math here, just really dividing and multiplying and adding up things. So let's do a common compound here, H2O water. So step 1 was, again, calculate the total molar mass. So we want to break up each compound by its elements. So hydrogen, the mass is 1, and I know there's 2 of them, so that's going to be 2. Mass of oxygen is 16. Again, I'm getting these numbers from the periodic table. There's one of those, and that's 16. So we want to add this up, and here I'm just rounding it off. If it's close to 0, it's okay that you round off these numbers. So the total molar mass is going to be 18 grams per mole. That's step 1, right? Calculate the total molar mass. Next, we want to divide the subtotal for each element. So that's going to be hydrogen and oxygen by the total molar mass. So what that means is for hydrogen I had 2, for oxygen I had 16. So I'm going to divide both of these numbers by the total here. The total was 18. So I get 0.11 and 0.89. Lastly, we want to convert these to percentages, so we're going to multiply by 100%. And that gives me 11% hydrogen and about 89% oxygen. So water is composed of 11% hydrogen and about 89% oxygen. Okay, so we just divided each element total by the grand total of the whole compound. And then we multiply by 100% to get the percentage. All right, let's do another example here. Sucrose, this one's a little bigger, C12H22O11. So again, break it up by element. Carbon, I know the atomic mass is 12, and I have 12 carbons, 144. Each hydrogen is 1, and here I have 22 of them, so that's going to be 22. Each oxygen is 16, and there are 11 of those. That's going to be 176. If I combine all of these together, I get a molar mass of 342 grams per mole. Okay, so we're going to use these numbers. Remember, now we want to divide each of these numbers by 342. So that's what I'll do next. I'm going to take this and divide it by 342. And then I also want to multiply these by 100%. I'm going to move this. So the total is 342. So after I do that, I'm going to multiply it by 100% as well. And let's see what numbers we get. So we get about 42% here. About 6.4% here. And about 51.5% here. We'll change this, sorry. 42.1%, that way everything adds up. Okay. And so you can always check your work by seeing that it adds up to 100%. But that's how you do percent composition. Again, you break up each element and then you divide it by the grand total. So each element total by the grand total times 100%. Here's a follow-up question that you might see. If I had 200 grams of sucrose, how many grams of hydrogen would it contain? So we want to take those 200 grams and we're just going to multiply by whatever the percent of hydrogen is. In this case, about 6.4%. But we want to convert that back into a decimal, so it's going to be 200 grams times 0.064. And we get about 12.8 grams of hydrogen. You can always check your math. If you do 12.8 over 200, then you should get that 0.064. Okay? So the answer here is 12.8 grams. All right, so hopefully with those two examples, you understand how to do percent composition. Go ahead and practice on that practice worksheet yourself. Feel free to rewatch this video or watch other videos.